Hello students, in this video we are discussing Cbse class 9 physics NCERT science textbook chapter 8 motion part 17. Okay, we've discussed the three equations of motion in the previous videos in part 14, 15 and 16. So in this video we'll be giving a quick recap, or I can say a comparison of all the three equations of motion. Okay, so the first equation of motion is velocity time relation. So as we all know, there are three. One is the velocity time relation, the second one is the position time relation, and the third one is the position velocity relation. So first one is velocity time relation. So we are calculating the slope first. Okay, we know that for a VT graph we can calculate the slope and the area. What does the slope give? The slope gives the acceleration and the area gives the distance or the magnitude of displacement. So first, for the velocity time relation, we are calculating the slope of the VT graph and it gives the acceleration of the object. Okay, so the acceleration A is equal to slope of the line AB. Before that, we have a general consideration for our graph. We are considering an object which is going to be moving with an initial velocity u, and then it travels for a time t and attains a final velocity v, okay, by giving uniform acceleration a, and in this motion it is covering a distance s. Okay, so all these are the consideration about the type of motion we are discussing here. So a is equal to what? Slope of this line AB. So for AB, if you want to calculate, I can calculate the rise divided by the run, or the vertical change by the horizontal change. So here it is going to be BD by AD. So my A will be equal to what? What is your BD? Your BD is V minus U. All these considerations are given here. Okay, so all these we've discussed very clearly in the previous videos. So if you have any doubt, please go into those videos and listen to all the three equations of motion independently. Okay, so A is equal to V minus U by T. We are multiplying this here. So we are getting AT is equal to V minus U. Okay, so for AT is equal to V minus U, we are getting V minus U is equal to AT. So we can write it as V is equal to U plus AT. Okay, so thus we get the first equation of motion. So this equation is also called the velocity time relation. Is it clear, children? Yes. Now we will get into the second equation of motion, that is your position time relation. So here also same consideration is what we are going to consider, but here we are calculating the area, because we know that the area will give us the distance s. Okay, so for that we are considering the area under the line. So if the area under the line abdina, here this is the graph abdina, all the area under this is going to be the area. So for this you have O, A, B, C. Okay, so area for this will be the rectangle and the triangle. Okay, so that we are considering. So area of the rectangle, area of the triangle. So we are substituting the values accordingly, and I told you that for the second and third equation of motion, till this it is going to be the same for both the second and the third equation of motion. So after this, since it is position time relation, we are substituting for V minus U. Okay, for the position velocity relation, we didn't want the time, so we brought all the time together. That we'll see next. So now look into the position velocity relation, as I told you, till this step. Okay, till this step it is going to be the same for the second and the third equation of motion. So after this, what are we doing? We are going to multiply t inside here, and then we are bringing all the VT UT terms individually, and we are combining the UT terms together. So we are getting half VT plus half UT, so half T into V plus U. So for T you have T is equal to V minus U by A. How? By V is equal to U plus AT. Okay, if you want AT, it will be V minus U is equal to AT, and when you want T, it is V minus U by A. Okay, so this is what you are substituting here for V minus U by A. So after that, you are taking the A outside, so it is 1 by 2A into V minus U into V plus U. which will be v square minus u square. So thus we are able to derive the three equations of motion. Is it clear, children? Now we'll get into a very quick summary. So this summary which I'm going to tell you now will give you a very easy comparison in such a way that you will never forget how to derive the three equations of motion. See, the first equation of motion, you are using the formula for slope to find the acceleration. Okay. For the second and the third, you are using the area to find the distance. So first one, you will directly get the value. Okay, v is equal to u plus at. The second one, what is substitution you are doing? V minus u is equal to at. Okay, and for the third one, you are going one step ahead by bringing all the t terms together. Okay, t terms all you are bringing it together, and then you are substituting for t is equal to v minus u by a, and thus you get the first equation of motion, second and the third equation of motion. Hope you are clear with the comparison of the three equations of motion. So please go through the video once again, the individual videos, the other parts if you have doubt. Okay, we have one more small concept, after which we will be completing with the concepts this lesson. Okay, thank you, children.